A pleasant greetings to all. In this video, I am going to explain sequence networks of a loaded generator. Figure represents three-phase synchronous generator with neutral ground through an impedance is Zn. The generator is supplying a three-phase balanced load. The generator or machine is supplying three-phase balanced load. Applying Kirchhoff's voltage law to each phase we obtain. I am going to apply the Kirchhoff's voltage law here. So this is the current direction. Current entering is positive and leaving is negative. Here generator voltage. And this is the direction of the neutral current. So entering is positive and leaving is negative. From this I am going to write the equation VA plus IA into Zs minus EA plus IN into Zn equal to 0. From this how to write VA equal to EA minus Zs into IA minus Zn into IN. This is the equation number 1. In the similar manner, I am going to write phase voltage B. BB is EB minus Zs into IB minus Zn into IN. And what about VC? VC is EC minus Zs into IC minus Zn into IN. Number 2 and number 3. Then I am going to substitute the neutral current. So what is neutral current? Neutral current is flowing towards this terminal. So here three currents are divided. One is IA, IB and IC. So IN equal to IA plus IB plus IC. And the next step what I have to do, I am going to substitute this IN in the equations 1, 2 and 3. I am going to apply the equations. So VA equal to EA minus Zs into IA minus Zn into, I have to substitute the value IA plus IB plus IC. Next, I am going to rewrite the equation as EA minus Zs into IA minus Zn into IA minus Zn into IB minus Zn into IC. Rearrange the equation like this: EA minus Zs plus Zn into IA minus Zn into IB minus Zn into IC. So this is VA. In the similar manner, VB equal to EB minus Zs plus Zn into IB minus Zn into IA minus Zn into IC. So what is VC? VC I have to apply IN. So EC minus Zn into IA minus Zn into IB minus of Zs plus Zn into IC. So 3 equations are over. After finishing this, have to write this in a matrix form. So VA, VB, VC, that is equal to EA, EB, then EC, then have to put minus. First I have to write the coefficient of IA, that is Zs plus Zn, then coefficient of IB, Zn, coefficient of IC also Zn. In the similar manner, here Zn, Zs plus Zn. Here Zn. Zn, Zn, Zs plus Zn. Then write in a matrix form, that is Ia, Ib and then Ic. Afterwards, or in a compact form, we are going to write VABC, that is equal to EABC minus ZABC into IABC, where VABC is the phase terminal voltage vector. VABC is what? Base terminal voltage vector. Phase terminal voltage vector. And what is IABC? IABC is the phase current vector. Phase current vector. Transforming the terminal voltages and current phasors into their symmetrical components. Okay, what is the result? That is A into B naught 1 2, that is equal to A into E naught 1 2 minus ZABC into A into I naught 1 2. Multiplying A inverse on both sides of the equation, we get B naught 1 2, and the right hand side we get E naught 1 2, and here A inverse is ZABC into A I naught 1 2. How to write E naught 1 2 minus Z naught 1 2 into I naught 1 2, where Z naught 1 2, that is equal to, what is the value? A inverse, that is 1 by 3 matrix 1 1 1 1 A square 1 A square A. And next put the value here, that is ZABC, that is equal to Zs plus Zn, Zn, then Zn, here Zn, then Zs plus Zn, here Zn, then Zn, Zn, Zs plus Zn. And then you have to write 1 1 1 1 A square, then A, next 1 A square, that is A. Afterwards, performing above multiplication, we'll get the value Zs plus 3Zn, here 0 0 0 Zs 0 0 0 Zs. That is equal to, this is the zero sequence impedance, 0 0 0, and here Z1 0 0 0 Z2. And next, substitute the values EA0 1 2. EA0 1 2 is what? 0, EA and 0. And Z0 1 2 is what? Z0 0 0 0 Z1 0 0 0 Z2. Next, I am going to substitute these values in the equation already we have derived. So I have to use the equation V0, V1, V2, that is equal to 0, A1, V2, 0, EA, 0, minus Z0, 0, 0. Then 0, Z1, 0. 0, 0, Z2. Here how to write IA0, IA1, then IA2. Since the above equation is very important, we write it in a component form. So what is VA0? That is 0 minus Z0 into IA0. What is VA1? VA1 is EA minus Z1 IA1. And what is VA2? VA2 is equal to 0 minus Z2. Here Z1, Z2 into IA2. And next, for this, I am going to draw the sequence network. This is the zero sequence component of a voltage. This is positive sequence and this one is the negative sequence. Now I am going to draw the positive sequence first. So the center one is positive sequence component. So in a positive sequence, here this is IA1, this is Z1. Then EA. EA is positive, negative EA. This is VA1, positive sequence network. And I am going to draw the negative sequence network. Negative sequence network. In a negative sequence network, there is no voltage source. Only we are having the impedance Z2 and here what? IA2. This is positive negative VA2. And next zero sequence impedance. Zero sequence network. So zero sequence network also impedance only. Here I have to write IA0. And here positive negative VA0. That's all. These are the sequence network for the loaded generator. We make the following important observation from this. The three sequences are independent. The positive sequence network is same as the one-line diagram used in studying balanced three-phase current and voltage. Only the positive sequence network has a voltage source. Therefore, the positive sequence current causes only positive sequence voltage drop. There is no voltage source in the negative or zero sequence network. Negative and zero sequence current cause negative and zero sequence voltage drop only. The neutral system is the reference for positive and negative sequence network, but ground is the reference for zero sequence network. Therefore, the zero sequence current can flow only if the circuits from the system neutrals to ground is complete. The grounding impedance reflecting on zero sequence as 3Zn. The three sequence system can be solved separately on a per basis. The phase current and voltages can then be determined by superposing their symmetrical components of current and voltages respectively. Here the per phase currents. That's all. Thank you. Have a nice day.